So good afternoon, everyone. Myself, Nishant, currently working as a senior R&D engineer at Tempsens Instruments. So I am the one who will be responsible for this non-invasive metal clamp sensor. So today we will be discussing about our new product, non-invasive metal clamp sensor, and give you a brief idea about how this sensor works and what are the target industries and what are the advantages of this sensor over the conventional sensors. Okay. So basically, Tempsens has developed a non-invasive metal clamp sensor which measures the temperature of an inside a pipe of a process medium without any intervention or without any drilling of any hole. So the detail about this sensor will be given in next few slides. So before going into the depth of the product, I will give you a brief idea about our company, Tempsens. So basically, Tempsens business area 21 and 22 were like 53% of sales revenues come from the temperature sensors. 33% of the sales revenue came from the cables and the 14% of the sales revenue came from the heating solutions. So for the temperature sensors, we have like two types of company. One is the accurate sensing technology and one is the AccuOpt. So one is contact type and another one is the non-contact type of sensors. Then another unit is on the cables which make high temperature cables and other type of cables. And we also provide heating solutions and different type of heaters to different type of industries depending upon the application. So we are spread it globally. We have total 600 employees and we are spread 75 countries around the globe. Until now, we have applied total 9 patents and our year-on-year growth is exceptionally 25%. And we have 40 years of experience in this domain of temperature sensing and thermal engineering solutions. So we are also having good R&D in these domains. Like we are developing new products day by day and like giving new type of solutions to the industries. So the key products in our temperature sensors are thermocouple, RTDs, thermowells, gauges, pyrometers, thermal imagers, calibration bath, and furnace camera also. We also have fiber optic sensors, wireless temperature transmitters, and the thermowells and nickel conductors. We also do provide thermal profiling system and data loggers for high temperature furnaces. The key products in our cable department is the thermocouple and RTD cables, high temperature cables, special cables, mineral insulated and metal sheeted cables, instrumentation signal cables, and LV control and power cables. Our key products in heating systems are cartridge heaters, band heaters, flexible heaters, tubular heaters, bundle rod heaters, process heaters, and various kind of heaters depending upon the user application and the industry. We also have our enable accredited calibration lab in all over the India. Total, right now we have total 4 labs in our manufacturing hub Udaipur, Bangalore, Baroda. So before like now we can start about the non-invasive clamp sensor. So before going in depth about of non-invasive clamp sensor, I will tell you like what are the problems with the conventional sensors which are used in industry. So there are two type of conventional sensors which are used to measure the temperature of a fluid inside a pipe. Basically, these are thermowells and the surface measurement sensors, basically stick-on RTDs or surface temperature sensors. So in thermowells, the major problem is that like it takes a lot of time to do to install the thermowells. So there is a process downtime. You have to stop the process and then drill the hole and put the thermowells inside the pipe to measure the temperature. So a high installation time, drilling time is required, and there is also chances of high leakage at high pressures. Installation difficulties and high downtime is also there due to the like manual power and like there is a you need to stop the production or you need to stop the pipelines to install the thermowells. And there is also chances of breaking of thermowell sensing element due to the sudden flow rate increase or decrease in the medium of the fluid of pipe. So the major drawback of these conventional sensors are like one is the downtime and the drilling time which you required. Another one is the process contamination through the thermowell to the process medium. In pharma industry, you can not afford any process contamination of the of the fluid through these thermowells. And another thing is like the breakage of the sensing elements. So this is the basic schematic how these three type of sensors are used in industry. So basically there is a process medium flowing inside a pipe. So this is a conventional non-invasive type of temperature sensor, which is basically a thermowell. Another one is the surface temperature sensor, which you stick on the surface of the pipe and assume that the process temperature is same as the surface temperature. And another one is our indigenously developed non-invasive climate sensors. Third one is the surface temperature sensor, and third one is the thermowells. So in thermowells, as I previously mentioned, the drilling time is required and the process contamination and the breaking of sensitive element is there. So there are various kind of drawbacks with this thermowell invasive kind of temperature sensor. And also in a long pipeline, you need to install different type of, at a particular distance, different type of thermowells. Instead of eliminating all these problems, we can use this non-invasive clamp sensor. You just need to put this sensor below the pipe, check the temperature, then again unclamp it and put it on another side. So no process intervention is there, no drilling is there. Only you need to just clamp on the sensor on the pipe. So I will show you the schematic view of this sensor in next few slides. And one more thing is the surface temperature sensor. So this is a non-invasive method, but the accuracy is very poor in this kind of sensors because of majorly two reasons. So conventionally, non-invasive surface temperature sensor measure the temperature of the surface of the pipe. So which does not compensate temperature difference between the ambient and the fluid inside the pipe. It assumes the temperature of the uh, process as the temperature of the surface of the pipe only, and and it does not compensate the effect of ambient on the surface temperature. Hence, its accuracy is very low as compared to the invasive type of thermowells and the non-invasive type of clamp sensor. So how these non-invasive, how this non-invasive clamp sensor eliminate all these problems to this conventional sensor. So basically, first thing is the simplified temperature measurement. You don't need to drill, you don't need to have a downtime. You just plug and play is there. You just need to put the sensor below the pipe and measure the temperature. And it also eliminates the possible leak points. And the surface temperature sensor have, as I previously mentioned, they have like inaccuracies due to the improper compensation of ambient temperatures. So this sensor comprises of two things. One is the heat flux sensors and one is the RTD. So I will give you brief idea how this sensor work and how this sensor gives an accurate temperature of the fluid inside the pipe without any intervention in the pipe, without any drilling or hole. You just need to see the stick on the pipe and you get the exact temperature inside the pipe. So this is the basic analogy or basic funda behind the working of this metal clamp sensor. So this is an inverted image of the sensor. Generally, the sensor will be below the pipe because due to the gravity, fluid will be always in the downside of the pipe. So you need to have a full contact with the with the pipe where fluid is traveling. So basically, from the first law of thermodynamics, what happens is that like there is a heat transfer from the hot medium to the ambient. So this heat transfer is proportional to the temperature outside the pipe, that is the surface temperature, and one is the process temperature. So if we know the heat flux which is coming out from the pipe, like how much amount of heat is coming out from the pipe, and if we know the outside temperature of the pipe, that is the surface temperature of the pipe, we can give the inside temperature of the pipe. Like, but it also depends on the material thermal conductivity and material thickness. So we have like given some factors of in our, we have developed some algorithm in which you can account all those factors. So this R thermal is a function of thickness and the thermal conductivity of pipe. Say it is a copper pipe, so it will be having a very high thermal conductivity. SS316 pipe has a very low thermal conductivity as compared to copper pipe. So you just need to select the pipe in the software, then it will give you ultimately the accurate results irrespective of the pipe dimension, pipe material and pipe thickness. So this is a basic funda. If you know the T surface temperature, which is basically T out, you know the heat flux and you know the thermal resistance of the pipe, then you can give the exact temperature of the fluid inside the pipe without any intervention or without any drilling of hole in the pipe. So I will explain, like this is the basic software of this non-invasive metal clamp sensor. So here you can see we have 4 to 5 kind of times. So this is a basic crude software. So we have developed much more detailed software right now also. So you can see here we have like comport, home, single point calibration, 2 point calibration, pipe selection. So in single point calibration, like if you want to make like from the factory point of view, we are giving calibrated sensor, but if you want a single point calibration also in the on-site calibration, then you can calibrate according to that by clicking on single point calibration. We we also have 2 point calibration, in which you can like there are two type of temperature, like you need 2 points to calibrate the sensor. So the raw sensor, the reference signal you need to put it out via using the in conventional thermowells to do this 2 point calibration, because you need to have some kind of initial set points to calibrate the sensor. The sensor gives approximately plus minus 3 degrees Celsius accuracy. But if you want accuracy less than 1.5 degree or 1 degree Celsius, then 2 point calibration is suggested. So here also you can see that we have given a pipe selection option. So in pipe selection option, you can choose the pipe which you are using. One is the schedule 40 SS321 material, one is the schedule 8316 material, one is schedule 40 GI material, galvanized iron material. So you can choose the standard pipe here, and then you can get the accurate results from your from the invasive clamp sensor. In case if you have any kind of alloy which you don't know the, and you don't know the conductivity, and you don't know the thermal conductivity and the thickness of the pipe, you can go for the custom pipe selection. So in the custom pipe selection, we define some kind of factor. So I will select one thing. So you need to adjust the factor here, like on-site calibration need to be there. You need to put the factor from 0 to 5 and check at what point you are getting exact temperature. If you don't know about the material of the pipe and don't know about the thickness of the pipe, that's the case. So here it is for the like any pipe which we have not shown here. So you can put the factor like calibration factor here, and then you can get the exact results for that pipe also. So this can vary from 1 to 5 and more than that also, depending on the pipe material and thickness. Once you set this, then you can will get the exact temperature of the pipe, of the fluid inside the pipe. So I will show, like I have g- shown the result of an experiment. Here we have gradually increased the fluid temperature inside a pipe flowing inside a SS316 pipe. So here we are getting the temperature of the pipe. So what are the major application industries of these sensors are like those industry where you don't need any intervention or drilling of hole inside the pipe. You just need a sensor to check the temperature of inside the fluid of the pipe, and it can eliminate use of various thermocouples, like various thermowells. If you are using right now 10 thermowells, you can use a single this sensor and clamp it, check the temperature, then unclamp it, then again place it to another location, check the temperature. And also in the this sensor is designed for low viscosity media, basically water based liquids, and also high viscosity. If you have another specific kind of flow inside your pipe, then you can tell us, we can modify the algorithm according to that and give you the sensor for that purpose only. So these sensor can be used in oil and gas industries, food and beverages, in dairy products where you want to measure the temperature inside a pipe of the milk and all those things. In refinery and brewery, so in breweries, in alcohol breweries, you need to check the temperature of the uh, raw material inside the pipe, and in also the pharmaceuticals. So in all those industries, process contamination is plays a huge role. So it eliminates the process contamination, corrosion, and like downtime. All those things is eliminated. You don't need to shut down your process to install the sensor. You just need to clamp the sensor and take the readings. So as I mentioned in the previous slides, the sensor is connected to one electronics box where it shows the digital reading of the temperature. So it a small electronic box is attached to it, and you can get the readings of the temperature. What this temperature is, was this sensor is showing. So this is basically a sensing head. Another part is the electronics also. So what are the major features of this uh, clamp sensors are is the accuracy and response time is very much closer to the invasive type of thermowells, and even though better than the invasive type of sensors, and it is also very much accurate than the service temperature sensors. So plus minus 2 degree without any drilling of the hole inside the without any hole you can measure the temperature. So it's a easy and faster installation via clamps, so there is no need of drill. Reduction in mechanical design, you just need to clamp it, just screw tight the sensor and you can get the results. And plug and play interface is there only. You just need to clamp the connect the USB to the software, you get the exact readings of the fluid inside the pipe. So the basic idea about this sensor is so the temperature range of this sensor goes from 0 to 100 degrees Celsius. The ambient temperature goes from 0 to 40 degrees Celsius. So as of now, we have developed sensor for 0 to 300 degrees Celsius also. But right now we are providing 0 to 100 degrees Celsius solution only. So when your temperature of the fluid is varying from 0 to 100 degrees Celsius and the ambient temperature is 0 to 40 degrees Celsius, we can give you plus minus 3 degrees Celsius accuracy, even plus minus 2 degrees Celsius accuracy. And when you do the 2-point calibration or 1-point calibration, you can get accuracy less than 1 degree Celsius also. The response time is basically 7 seconds. So these sensors are for the standard pipe size, made for the standard pipe sizes. So right now we are providing two size of pipes, for 1-inch pipe sensor and one for 2-inch pipe sensors. So for 2-inch pipe sensors, like for more outside diameter of pipes, we can customize the sensor head and give it to you. We have analog output from 0 to 20 milliampere for this sensor and 4 to 20 milliampere. So there is a digital output of USB 2.0 RS-2332 to RS-485, which is an optional. At a times, only single digital output is possible. So there is a relay output so that you can get an alarm. If you need an alarm and you know that your temperature should not go over 80 degrees Celsius, it can give you a alarming signal, and then you can put a buzzer outside this and get the process in control. So adjustable parameter is also is there, so you can change the pipe diameter and pipe material. So basically these are factor accounted in the custom pipe functions. So any kind of pipe and any kind of pipe thickness can be accounted with these sensors. So the material construction is basically this sensor consists of two things. One is the heat flux sensor, which is a kind of a thermopile, and one is the surface temperature sensor. So basically the heat flux sensor measures the heat and the surface temperature sensors the T ambient. So the inaccuracies of the surface temperature sensors is accounted by those heat flux sensors, and the algorithm is designed in such a way that you will get the accurate readings approximately plus minus 2 degrees Celsius. So it is a mix of surface temperature sensors with some algorithm and heat flux sensor.